Reinforcement learning is like training a dog. If the dog does something good and gets a treat, it'll want to do it again. If instead it gets scolded, it'll try to avoid that. The same idea applies to AI agents. The agent gets rewards or penalties based on its actions. The agent's only goal is to maximize its total reward. Smart pole is a classic machine learning problem we can apply this to. Imagine a robot that can move left or right that's balancing a pole on top of it. But how can this robot see? How does it know what to do? The agent is fed its horizontal position, horizontal velocity, pole angle, and pole angular velocity. These four observations give it its understanding of the world. For training, the agent is given rewards based on how upright its pole is and how close it is to the center. Additionally, if the agent goes too far from the center or the pole falls too far, the episode ends and the agent restarts. It is given a negative reward to tell it, don't do that again. To train, I am using proximal policy optimization, a reinforcement algorithm with clipping to prevent sudden changes. Now finally, we can train the model. At first, the agent moves randomly and the episodes are really short. This is because it knows nothing. It's literally doing random actions trying to find the optimal policy. As it progresses, you can see that it gets better and better, and now I'm going to show you what happens after 1,000 episodes. So this is about 200 seconds of training. You can see that the model has sort of figured out how to get underneath the pole, and it can stop the pole from falling over. But it's still only lasting around 5 seconds a session, and also it's drifting too far from the center, so I'm going to change the reward function to try and prioritize it staying in the center more. Also, it's really slow, and that can be improved by just running multiple agents. So I'm going to run like 20 of them at the same time, and you should see that it'll train much faster. So here is 21 agents training all at the same time, and as you can see, it's absolutely like obliterating the episode, just blasting through them. The reward function, it's increasing, but like, you'll see that it should slowly start to increase and go up, and it's getting there. So I'll show you what happens after this trains for 200 seconds. As a result, you can see it's doing much better. It's kind of figured out what to do. And also I'll put the episode length and value loss graphs on the screen so you can see what's going on statistics wise. But yeah, if you're interested, the code is in the GitHub in the description. Peace.